Okay, now let's look at some more examples. At this point, what you can do is you can pause the video and try to solve this equation. And if you are able to, you can verify the answer. If not, you can proceed with the video and look at how to solve it. The two equations are 2x plus 3y equals negative 7, 3x minus 2y equals 4. Now, one thing that I want you to visualize whenever you look at an equation is that remember these are straight lines. And the straight lines can either intersect, be parallel, or coincide. Okay. Now, first observation here is I cannot directly add or subtract and get rid of any one of the variables, right? Because I have a 3y and a negative 2y, which means adding them means I would be left with a y. Similarly, 3x and 2x, if I subtract, I would still be left with an x. So what we do is we make some changes or we rewrite the given information so that we can get rid of one of the variables. Now, one of the observations I can make is that 3 times 2 is 6 and 2 times 3 is also 6, which means that I can rewrite 3y times 2 as 6y and negative 2 times 3 as negative 6y. And I know 6y minus 6y is 0. So I can multiply the first equation by 2 and the second by 3. A couple of questions that questions that should arise in your mind is, why can we do this? Well, it's an equation, remember? So as long as you multiply both sides of an equation, it remains the same. It's kind of like a balance. Why choose the numbers 2 and 3? Because we realize that by doing so, we end up with a positive 6y in one equation and a negative 6y in another, which then can be added, like our previous example, to get rid of the y. So do that. This gives us the following equation. When we add, it ends up with 13x equals negative 2 and x is negative 2 over 30. Now again, over here, you can finish this problem. You can try it out, complete on your own. Plug this into either one of the equation to find the value of y. Once you found it, you can verify it should be negative 95 over 39. Okay, let's proceed. Look at a couple more examples. Let's say I have 2x minus 2y is 3, x minus y is 2. Now this time, in order to cancel something, we just need to multiply the second equation by 2, and we end up with 0 equals negative 1. Now, is that a valid equation? The answer is that it is not. Which means that what this is saying is, when I try to solve this system of equation, I end up with an invalid equation. I end up with something like 0 equals negative 1, which means that I cannot solve this system of equation. Another way of phrasing that would be to say that it has no solution. What that means is that algebraically, there are no values of x and y, which makes both the equation true. And geometrically, it means there is no point xy that lies on both the lines. So now recall from the pictures, when does that happen? That happens when the lines are parallel. So this means these lines are parallel to each other. The next example here, I multiply the first equation by 2 and I subtract and I end up with 0 equals 0. Is that valid? That is valid. 0 always equals 0, which means that there are infinitely many solutions, because what's happening here is when you're trying to solve this equation, you end up with a statement which is always true, irrespective of the values of x and y. What this means is no matter what value of x and y you choose, algebraically both equations will be satisfied, and geometrically all those points are going to lie on both the lines. Now remember, this is the case when we drew the picture of coinciding lines. Okay, so these were examples each of intersection, unique solution, parallel, no solution, and coinciding, infinitely many solution.